All right, here are the example problems for the unit circle section 1. I noticed that the video is getting a little long, so I thought it might be easier to do the homework on a separate sheet. So kind of reviewing all the problems that we looked at. Make sure you've got your unit circle down, the degrees, the points, and the radians. And so the first example that we were going to do is to try to find the sine of 5 pi over 6. Now, most of these unit circle problems are basically, they're things you can do in your head, but I want you to show me what it is that you're thinking, and so here's how you do it. So the first thing I recognize is it's asking me for the sine. And if you remember when we drew out this stuff, we said that if we're on the unit circle, the sine is really the y value. So what I'm going to do is I'm going to say that this is asking me for the y value at 5 pi over 6. So I recognize it's the y value that they want me to find. The next thing I'm going to do is look at this fraction. Does that fraction simplify? 5 over 6? No, it doesn't simplify. So now look at the denominator. We said that if there's a 6 in the denominator, it's a 30-degree reference angle, and that there's my x and y value. So I know this is a 30-degree reference angle, and that my point should be square root of 3 over 2, 1/2. Now I don't know whether they're both positive, both negative, one positive, one negative, but I know those are the x and the y values. And so I know it's a y value because of the sine. I know it's a 30-degree reference angle because of the pi over 6 part of it. And now what I'm going to ask you to do for work is draw yourself a quick little unit circle. You don't have to draw in all of the little rays. You're just going to put the x and y axis on there. And then what you're going to do is you're going to draw the ray where 5 pi over 6 is. Think about it. This is just a little bit less than 1. This is 1 pi. Remember, we're moving a positive way, so we're going that way around. So if I were going to go a positive direction just less than 1, I would be right about here. Remember, the reference angle is 30 degrees, so this should be about 30 degrees. So here's where I'm at. And now if you think about it, you have to move to the left and then up. So you have a negative x, positive y. So the point that you're really dealing with is negative square root of 3 over 2, 1/2. Now realistically, like I said, that's all stuff that you would be doing in your head, but I need to see your work in terms of what you're thinking, and it'll help you to do this, to write this out. And then as you get really good at this, you'll be able to just think your way through it fairly quickly. So now to answer the question, it said what was the y value? Well, your final answer would be 1/2. That's the y value at 5 pi over 6. So I move on to the next one, letter B. It asks me for the secant. Now, for me, I'm very good at and comfortable with the sine, cosine, and tangent, the 3 original trig functions. When it comes to the secant, cosecant, and cotangent, not as comfortable with those because we don't work with those as often. So what I'm going to ask myself is, what's the reciprocal of secant? So if you can't remember it, you look at your little sheet here and it says that the cosine is the reciprocal of secant. So what I'm going to do is I'm going to actually find the cosine of negative 3 pi over 4. And then let's just say by chance that that was the answer. What I will do is, since I took the reciprocal of the original trig function, what I would do is I would take the answer and I would just flip it over and I would say it's 2, for example, if this was my number. So, need to know which trig function is the reciprocal. It's cosine. And now it's asking me what's the x value, or if you want to be more exact, since it's really the secant, it's really the 1 over x value. But you can ignore that for now. You can just tell yourself it's the x value at negative 3 pi over 4. Again, check to see if that fraction will simplify. It won't. That means 4 is your denominator. So that's a 45-degree reference angle. And that means that my point is the square root of 2 over 2, square root of 2 over 2. And of course, I'll know that just by knowing my unit circle. All right, now I'm going to go ahead and draw out a little unit circle. And now remember that this angle is negative, so I'm not going counterclockwise. I'm actually going that way around the circle. Now it's a 45-degree reference angle, and you're moving 3 of them. So you can count them out if it helps you. You can say there's 1, 2, there's where the third one would be. And now it's negative, negative, so the point you're really dealing with is negative square root of 2 over 2, comma, negative square root of 2 over 2. So now I got the point that I'm looking for. I again want the cosine value, which is this one, and I actually want the reciprocal of it, so I'm going to flip it over. It's going to be negative 2 over the square root of 2, and then of course I want to rationalize that like we learned to do in one of our other homework sections where I Multiply both numerator and denominator by square root of 2 over square root of 2. And that would give me negative 2 square roots of 2 in the numerator divided by 2 in the denominator. The 2's cancel, and so my simplified answer should be negative square root of 2. And so once you get comfortable doing these, you'll see these things actually go really, really fast. You just have to get used to doing it, and that'll come with time. So make sure that you are giving yourself the time that you need. Now when I move on to letter C, it's the same concept. Don't let the 2 bother you. Basically, you're going to do the same thing with the sine of pi over 4. It's just whatever the answer is, you multiply it by 2 at the end, and then you subtract another answer. So let's start with the sine of pi over 4. Now I recognize it's a y value, and I recognize that it's over 4. So I know I'm dealing with a 45-degree reference angle, which means I'm looking at the square root of 2 over 2. Square root of 2 over 2 is my x and y value. I know it's the sine, so I want the y value, but again, I have to figure out which quadrant it's in. Pi over 4, it's a 45-degree reference angle, it's positive, so going that way, it's 1 pi over 4, it's here. They're actually both positive. So the sine, or y value, is going to be positive square root of 2 over 2. So it's 2 times square root of 2 over 2 minus, and now let's do the tangent one. Well, tangent, what was tangent? Well, we said when we were on the unit circle, tangent was the y value divided by the x value. So I noticed that this fraction won't simplify, and it's over 3. So I'm looking for the y divided by x value at, and this is going to be a 60-degree reference angle, which means my x value has got to be 1/2, and my y value is going to be square root of 3 over 2. I again just have to figure out what sine it is. Well, I'm moving a positive angle. Notice the difference here. The negative in front is not the angle, it's the negative on the actual angle that makes it go that way instead of this way. Alright, so negative pi over 3, I'm going to move one 60-degree angle, which would put me here. Again, that's to the right and up, so those are both positive. Now it's the tangent, so it's the y value divided by the x value. Now I'm going to do that down here and show you that if I take the y value, divide it by the x value, remember when you divide by a fraction, you really multiply by the reciprocal? So I'm going to take the reciprocal, which would be 2 over 1. Do you see that the 2's cancel? That's always going to happen on the unit circle. If the denominators are the same, they basically are going to cancel each other out when you go to divide. So if I take the y divided by the x, I really just get the square root of 3 over 1, which is implied. I don't need that. Now when I go ahead and try to actually figure out what this is, the 2's would cancel. I'm going to end up with the square root of 2 minus the square root of 3. Those are not like terms. You remember one of the other homework sections we said that not only does the root number have to be the same, which they are, but the number inside has to be the same. This is actually your simplified answer, and that would be exact. Alright, so hopefully you have some success doing those types of problems on the homework. The last 3 types of problems that we're going to do are similar in nature. They're going to ask us to list off the 6 trig functions, so now we're going to end up doing this. And these points that we are given, you'll notice that if you found the radius, like if you move 3 to the right and up 4, you're clearly not on the unit circle. You've moved a distance bigger than 1. So we're going to be using our SOHCAHTOA stuff. And so I'm going to find sine, cosine, and tangent first, and then once I have those, I'll just flip the fractions over. So what I would ask you to do for this homework is go ahead and draw yourself a little picture. You don't need to be exact, but the 0.34 would be somewhere over here in the first quadrant, and what you're going to do is you're going to draw a right triangle. Now when you do this, you're using reference angles, so you have to go from the point to the x-axis, which is this one. So it always has to go to the x-axis and then go from that point to the origin, and that'll give you your right triangle that you're looking for. The x value is 3, that's that side length. X value of 4, there's that side length. A squared plus b squared equals c squared, that's a Pythagorean triple that you might remember. That's eventually going to give me 5. Now the angle that we're talking about is always the one by the origin here. So now I just have to start listing off my trig functions. So let's start with the sine of theta. Sine is opposite over hypotenuse, so 4/5. Simplify your fractions as you go if you can. Cosine is adjacent over hypotenuse, so 3/5. Tangent is opposite over adjacent, so 4/3. And now you just have to do the reciprocals. I know the reciprocal of sine is cosecant, so I'll just put that right next to it, making it a little easier for me. Just flip the fraction over, it'd be 5/4. The reciprocal of cosine is secant, so again, flip the fraction over, it would be 5/3. And the reciprocal of tangent is cotangent, and that will give me 3/4. And so you should have 6 answers for all these. And that's basically all you're going to do, is you're going to draw your triangle and then list them out. So letter B, nothing majorly different other than the fact that you're going to the left and then up, so you're going to draw your triangle in the second quadrant, but nothing majorly different. The point would be over here. You're again going to go to the x-axis, go to the origin. Here's the angle that you're looking at, the one by the origin. When you draw your triangle, you're probably not used to labeling with a negative number because you're thinking of distance, but even though it is distance, you're trying to represent the direction it's going also. So I do need to label this with a -5, so pay attention to signs. That's going to give me 7, and now the hypotenuse isn't one that's as easy to figure out. It's not a Pythagorean triple that you're used to, so you're going to do a squared, or -5 squared, plus b squared, or 7 squared, equals c squared. And we're going to want this to be exact, so no decimals, we're going to keep it as a radical. That's going to give me 25 plus 49 is equal to c squared. Or if I add those together, it looks like I'm going to end up getting 74. And then go ahead and take the square root of both sides, so c is going to equal the square root of 74. Now if I can simplify that, I should try to. And I can see that 74 is divisible by 2, because it ends in a 4, so maybe I try to divide it by 2 quick. And I know if I figure that out, it's going to be 2 times 37. 2 is prime, and so is 37. So that actually is simplified. Now you might also be asking, shouldn't there be a plus or minus? Yes, but the hypotenuse always has to be positive. If it was one of these side lengths, then it would make a difference, positive or negative, and then you just have to pay attention. For that one, it would have to be negative. For this one, it would have to be positive because of the direction that you're moving. All right, once you've got the triangle filled out, which basically it just comes down to getting the hypotenuse, now you can go ahead and find all the sine, cosine, and tangent stuff. So let's start with the sine. Sine of theta, now opposite would be 7 over the square root of 74. Remember, you want to rationalize. So when you say 7 over the square root of 74, you want to rationalize right away and do the square root of 74 over the square root of 74. So I'm going to say that this is 7 square roots of 74 over 74. If the 7 and 74 have something in common, you should simplify it, but they don't. Cosine theta. Cosine would be -5 over the square root of 74. Same thing, I want to rationalize. So it's -5 square roots of 74 over 74. Tangent of theta, a little bit easier, will be 7 over -5. Doesn't really matter where you put the negative, whether you put it on the top one, the bottom one, or just right beside it. And now I'm running out of room here, so I'm just going to go straight down. The reciprocal of sine was cosecant. So flip that fraction over. Now remember, this originally was the cosecant. I rationalized it to get this. Now the reason I bring that up is if I flip this over, I'm going to have a radical in the bottom. What if I just flip this over to begin with? Then I don't have to worry about rationalizing. It would be the square root of 74 over 7. And that's the same thing that you're going to get if you flip this over and then continue to rationalize. Same thing for the cosine. I'm going to find the secant. The cosine, I didn't write it out, but the cosine would have been -5 over the square root of 74. That was unrationalized. We'll flip that over. That'll be a little bit easier to deal with. It would be negative square root of 74 over 5. And then the cotangent of theta is just the reciprocal of tangent, so that's going to still be negative, but it'll be -5/7. And there are my 6 trig functions. All right, letter C. It's 2/5 and 2/3. I'm going to go ahead and flip to the back to give myself some more space here. So letter C, we had 2/5, 2/3. Double check that to make sure. Yep, all right. Exact same idea. I'm going to go ahead and draw a right triangle. Now notice positive x, positive y. So when I draw this out, it's in the first quadrant. Again, I don't really care how accurate the triangle is in terms of size. I just need to have something to look at. And I know the x value is 2/5, the y value is 2/3, and what's going to make this more challenging is the fact that I've got fractions sitting here. Now, if you want to make this easier on yourself, and who doesn't, get a common denominator. It'll make your life a lot easier. So it looks like 15 is the common denominator. So if I multiply the first one by 3 over 3, it gives me 6 over 15. Multiply this one by 5 over 5 would give me 10 over 15, and I'm going to actually use those instead. They're clearly the same thing, so there's nothing wrong with doing this. And the reason I'm going to do that is you see the denominator is the same. Remember what we said back here when I went to divide with the tangent, how if the denominator is the same, eventually it was just going to cancel itself out. This is going to make it easier when I start dividing all the opposite over adjacent stuff. If they have the common denominator, all the 15s will cancel. What is also nice is when I have to do a squared plus b squared equals c squared, because 15's in the denominator, I don't know what the numerator is, but the denominator I know is going to be 15, so I can do this. I don't have to do the square root of 6/15 squared plus 10/15 squared. As long as I have a common denominator, I can just deal with the numerator, and I can just say it's the square root of 6 squared plus the square root of 10 squared, and just understand that the 15 is going to be there in the denominator. And of course, that makes it a lot easier than trying to deal with these fractions. Imagine if you would use these, you'd then have to get a common denominator. It just makes it a lot harder. It eventually would be the same thing, but why do it harder than you have to? Alright, so I'm going to go ahead and figure this out. That gives me the square root of 36 plus 100, or it looks like I have the square root of 136. Now, like I said before, if you can simplify that, I would do so. I can see it's even because of the 6, so maybe I just divide by 2 to start with. And so I figure that out, and it looks like that's going to go in there 68 times. Now, if you're not sure what it is right away, go ahead and do the long division on the side. There's nothing wrong with that. 68 is definitely even, so I know 2 will go into that. Happens to go in there 34 times. 34 breaks down to 2 and 17, so I can see I've got a group of 2. So what I'm trying to say is that this is eventually going to be 2 square roots of 34. And then, of course, it's over 15 again. So 2 square roots of 34 over 15. Alright, now that I've got all that drawn out, now when I go to list off my sine, cosine, tangent, like I said before, the 15s, they're all going to cancel. So I can almost just ignore them. It's not going to change anything. So let's start with the sine. I don't know why, I just always start with the sine. But the sine is going to be, ignore the 15s, it's going to be 10 over 6. And of course you want to reduce that like you always would, so reduce that down to 5 over 3. There's the sine. Cosine theta is going to be 6 over 2 square roots of 34. Now you have to multiply by the square root of 34 over the square root of 34 to rationalize, and in doing so you're going to get 6 square roots of 34 over 34 times 2, which is going to be, I'm going to just leave it as 2 times 34 because it'll make it easier to simplify. That's going to reduce to give me a 3. 3 won't go into the square root of 34, so this is going to be 3 square roots of 34 over 34. All these little tricks of not multiplying it out makes things so much easier, and you'll get used to doing stuff like that. I'll show that to you next year. Alright, tangent of theta, that's going to be, oh, okie dokie. You probably already caught this, sorry. This was actually the tangent. I don't know what I was thinking. So sorry, the tangent was 5 over 3. Stupid me. Let's go back and do the sine. The sine would be 10 over 2 square roots of 34. Sorry about that. So same concept as here. It's going to be 10 divided by 2 square roots of 34. Now if you want, you can just simplify this down to a 5 right away. And then I'm going to multiply by the square root of 34 over the square root of 34. And I would end up with 5 square roots of 34 over 34. Sorry about that. Hopefully you caught it. If you didn't, no big deal. Obviously I didn't. And now once you have these three, just go ahead and find their reciprocals. So the opposite, or sorry, not the opposite, but the reciprocal of sine is the cosecant. Again, I want to flip that over, or if you want, come back to here. Remember, that's what I had to begin with, and I flipped that over and then rationalized. Or if that's too complicated and too hard, you obviously don't have to do that. You can just deal with what you were working with over here. So let's pretend like I didn't know how to do that. Let's just go ahead and flip this over. That would give me 34 over 5 square roots of 34. Now I'm going to need to multiply by the square root of 34 over the square root of 34. And that's going to give me 34 square roots of 34 over 5 times 34. And those would cancel, and I'm left with the square root of 34 over 5. So I eventually got the same thing, regardless of how I did it. Sorry I'm being really messy on this one. That's not normally like me. Alright, 2 left to go. Let's go with the secant of theta. Secant of theta is the reciprocal of cosine. And if I flip that over, it's eventually going to give me the square root of 34 over 3. And then the cotangent, if I flip over the tangent or find the reciprocal of it, would be 3/5. So obviously a little bit more difficult because of the fact that you had to deal with fractions. Big clue, get a common denominator. That'll save you a lot of time. And then if you have a radical, of course, it's going to mean you have to do some rationalizing. But overall, hopefully you get the concept. Again, if you have questions, let me know. I'll try to help you out if you send me an email. Otherwise, best of luck. And that's your homework help.